Welcome to my channel Job Opening and Career. This channel is for education and career purpose. The Birla Institute of Technology and Science, BITS Pilani, is an all India institute for higher education. The primary aim of BITS is to train young men and women able and eager to create and put into action such ideas, methods, techniques, and information. Prepare for a career with infinite possibilities in AI and ML with India's most comprehensive and world-class M.Tech artificial intelligence and machine learning program without taking any career break. Artificial intelligence, AI, is a broad field of science and computer research that involves machines and computers that can perform tasks that typically require human intelligence. AI systems use technologies to enable machines to learn, reason, and act in ways that are similar, such as seeing, understanding, and responding to language, analyzing data, and making recommendations. AI systems can learn to recognize patterns and trends, solve problems, and predict future events by analyzing large amounts of data. They can also adjust to new inputs and perform human like tasks. The M.Tech Artificial Intelligence and Machine Learning is a work integrated learning program, WILP, spanning 4 semesters. BITS Pilani's work integrated learning programs are approved by the University Grants Commission, UGC. Attend live lectures from anywhere over an online technology enabled platform. These live lectures would be conducted by faculty mostly on weekends or after business hours, enabling working professionals to pursue the program along with their jobs. Offers the most comprehensive AI and ML curriculum for working professionals. The program has an unmatched range and depth and covers the widest variety of skill and knowledge areas required to develop advanced AI solutions. Meant for IT professionals and software developers aiming to become expert machine learning engineers and AI scientists. The program offers a set of core courses and elective courses, allowing students to gain expertise in advanced deep learning, computational learning theory, speech processing, natural language processing, etc. The program offers a set of core courses and elective courses, allowing students to gain expertise in advanced deep learning, natural language processing, etc. In the field of artificial intelligence and machine learning, the world is indeed standing on the threshold of massive transformation. According to the World Economic Forum's Future of Jobs report, 85 million jobs will be replaced by machines with AI by 2025. While that might make you uneasy, the same report states that 97 million new jobs will be created by 2025 due to AI. Are you prepared? Prepare for a career with infinite possibilities in AI and ML with India's most comprehensive and world-class M.Tech artificial intelligence and machine learning program without taking any career break. This 4 semester program covers a wide variety of skills and knowledge areas and enables IT professionals and software developers to build a skill set that enables career elevation in some of the most sought after job roles such as ML engineers and AI scientists, etc. The dissertation work in the final semester enables students to apply concepts and techniques learned during the program. The program uses a continuous evaluation system that assesses the learners over convenient and regular intervals. Such a system provides timely and frequent feedback and helps busy working professionals stay on course with the program. The education delivery methodology is a blend of classroom and experiential learning. Experiential learning consists of virtual lab exercises, assignments, case studies, and work integrated activities. Participants who successfully complete the program will become members of an elite and global community of BITS Pilani alumni. Option to submit fee using ECMI with 0% interest and zero down payment. Program curriculum. Semester-wise pattern. Participants need to take at least 12 courses towards coursework and complete one project dissertation. The coursework requirement for the program would consist of a set of core courses and electives. Core courses are compulsory for all participants, while electives can be chosen based on individual learning preferences. First semester. Mathematical Foundations for Machine Learning. Machine Learning. Introduction to Statistical Methods. Artificial and Computational Intelligence. Second semester. Neural Networks. Deep Reinforcement Learning. Elective 1. Elective 2. Third semester. Elective 3. Elective 4. Elective 5. Elective 6. Electives. Pool of electives for Deep Learning Specialization. Advanced Deep Learning. Graph Neural Networks. ML System Optimization. Fair, accountable, transparent machine learning. Pool of electives. NLP Specialization. NLP Applications. Social Media Analytics. Natural Language Processing. General Pool of MLOPS. Design of Algorithms. Computer Vision. Probabilistic Graphical Models. Data Management for Machine Learning. Video Analytics. Advanced Data Mining. AI and ML Techniques for Cybersecurity. And fourth semester. Dissertation. It is a long academic piece of writing based on a student's independent research. It is usually submitted in the final semester of courses. It requires a lot of research and written documentation. The aim of writing a dissertation is to test a student's research skills. It allows students to develop their research, problem solving, project management, and numerical skills. Mode of learning. The mode of learning in this program is called Work Integrated Learning. Internationally, Work Integrated Learning (WIL) is defined as an educational approach involving three parties: the student, educational institution, and employer organizations, consisting of authentic work-focused experiences as an intentional component of the curriculum. Students learn through active engagement in purposeful work tasks, which enable the integration of theory with meaningful practice that is relevant to the student's discipline of study and/or professional development. An education model can be as WIL if and only if the programs are designed and developed by the institute in collaboration with industry. Work-focused experiences form an active part of the curriculum. The program structure, pedagogy, and assessment enable integration of theory with relevant practice. The innovative Work Integrated Learning Programs, WILP, of BITS Pilani are quite aligned with the above definition and requirements. The programs are designed in collaboration with its industry partners, subject matter experts from industry and academia that enable the students to remain relevant in their chosen profession, grow in their career, and retain the habit of lifelong learning. The continued availability of workplace-related experiences along with the weekly instruction sessions promote integration of theory with practice. An active participation of the organization mentor in the learning process of the student plays a key role. Case studies, simulation exercises, labs, and projects further strengthen this integration. The WILP of BITS Pilani is comparable to its campus-based programs in terms of structure, rigor, instruction, labs, assessment, faculty profile, and learning support. The pervasive adoption of technology in all its academic processes makes the same high-quality education of BITS Pilani available to the aspirants at scale with the required flexibility. Learning outcomes at the program, the students will be able to demonstrate conceptual understanding and hands-on knowledge of traditional and contemporary AI and machine learning techniques, including deep learning and reinforcement learning. Demonstrate conceptual understanding and hands-on knowledge of AI application areas such as natural language processing, computer vision, or cyber security. Understand the system and software engineering requirements for implementing machine learning systems on large datasets and in resource-constrained environments. Understand the underlying ethical issues in applying AI and machine learning. Course-wise syllabus. Mathematical foundations for data science. Vector and matrix algebra. Systems of linear algebraic equations and their solutions. Eigenvalues, eigenvectors and diagonalization of matrices. Multivariate calculus, vector calculus, Jacobian and Hessian, multivariate Taylor series. Gradient descent, unconstrained optimization, constrained optimization, nonlinear optimization. Stochastic gradient descent. Dimensionality reduction and PCA. Optimization for support vector machine. Introduction to statistics. Methods. Basic probability concepts, conditional probability, Bayes theorem, probability distributions, continuous and discrete distributions, transformation of random variables. Estimating mean, variance, covariance. Hypothesis testing, maximum likelihood, ANOVA, single factor, dual factor, time series analysis, AR, MA, ARIMA, SARIMA, sampling based on distribution, statistical significance, Gaussian mixture model, expectation maximization. Deep neural net. Introduction to neural networks. Approximation properties. Backpropagation. Deep network training. Regularization and optimization. Convolution neural networks. Recurrent neural networks. Attention models. Transformers. Deep reinforcement. Introduction and applications. Markov decision processes, MDP. Tabular MDP planning. Tabular RL policy evaluation. Q-learning, model-based RL. Deep RL with function approximation. Policy search, policy gradient, fast learning, applications in game playing, imitation learning, RL for neural architecture search, batch RL. Advanced deep learning. Introduction to representation learning. PCA and variance, likelihood-based models, flow models, autoregressive models, latent variables. Deep autoencoders, Boltzmann machines, generative adversarial learning, variants of GAN and applications. Deep dream, neural style transfer, self-supervised learning, semi-supervised learning, language model learning, applications in time series modeling, representation learning for reinforcement learning, deep clustering. Basics of graph theory. Machine learning on graphs, node embedding, link analysis, representation learning for graphs. Label propagation for node classification, empirical risk minimization, graph convolutional filters. Composition with pointways nonlinearities, permutations, dilation and stability, transferability, graph RNN, algebraic neural networks, applications of graph NN in subgraph mining. Recommendation systems, community structures and networks, deep generative models, knowledge graph embeddings, and reasoning. ML system optimization. Review of parallel and systems. System performance trade-offs. Distributed machine learning for large models and datasets. General purpose distributed computing frameworks, Hadoop, MapReduce, and Apache Spark. Deep learning frameworks and runtimes, deep learning hardware, deep learning compilers with optimizations, scalable training and inference serving, parameter serving, federated learning, model compression for optimizing communication and resource constrained devices. Case studies of machine learning on single GPU systems, on GPU clusters. Fair, transparent machine learning. Biases and fairness. Fair representation learning, interpretability and transparency. Example and visualization based methods for interpretability. Interpreting deep neural networks, fairness through input manipulation, fair NLP vision, robustness and adversarial attacks defense, ML auditing, privacy. NLP sentiment analysis, grammar and spelling checkers, cross-lingual language models, machine translation including Indic languages, question answering and chatbots, information extraction, named entity recognition, relation extraction, knowledge graph, social media analytics, social media platforms, NLP in SMA, text summarization, opinion science and dynamics, MLDL in SMA community detection, ethical social media, case studies role of social media in disaster management, FM driven mental health and behavior analysis, MLOP adaptation of DevOps for building and deploying machine learning systems, model deployment, infrastructure requirements, deployment patterns, model CI/CD, build, test, integration and delivery of model serving tools and technologies, model life cycle management, ML pipelines with data management support, model assessment, evolution, and management in production, MLOps infrastructure and tools. Trends in model deployment, ML on the cloud edge browsers, VMs, containers, Docker, Kubernetes, K8s, FireSys, ML as a service. Design of algorithms. Review of important data structures. Design techniques such as divide and conquer, greedy, recursion, backtracking, branch and bound, simulation. Dynamic programming, examples, analysis, general structure of solutions, limitations, and applicability. Illustrations dealing with problems in AI and machine learning. Computational complexity and bounds, NP-hard and NP-complete problems. Introduction to approximation algorithms, randomized algorithms. Computer vision. Image formation, structure, and transformations. Low-level, filters, features, texture. Mid-level, segmentation, tracking, morphology, and high-level vision, registration contour geometry. Object detection and classification, segmentation. Deep learning for object detection. Recognition. Face detection and recognition. Facial key point recognition. Optical character recognition. Vision. HM. Markov random field. Bayesian networks. Representation. Learning, inference. Dynamic Bayesian networks and temporal Bayesian networks application. Data management for learning. Data models and query languages, relational, object relational, NoSQL data models, declarative, SQL, and imperative, MapReduce, querying. Data encoding, evolution, formats, models of data flow, machine learning workflow, data management challenges in ML workflow. Data pipelines and patterns. Data pipeline stages, data extraction, ingestion, cleaning, wrangling, versioning. Transformation, exploration, feature management, modern data infrastructure, diverse data sources, cloud data warehouse and lakes, data ingestion tools, data transformation and modeling tools, workflow orchestration platforms, ML model metadata and registry, ML observability, data privacy and anonymity, natural natural language understanding and generation, engram and neural language models, word to vectors word embedding, skipgram CBOW, GLOF, BERT XLM, Mural, part of speech tagging, hidden Markov models, parsing, syntactic, statistical, dependency, word sense disambiguation, semantic web ontology, video analytics, digital video, spatiotemporal sampling, low-level features to high-level semantics, video enhancement technologies, denoising, stabilization, unsharp masking, super resolution, background modeling and foreground detection, ML techniques for video motion detection, tracking, compression, indexing and retrieval, browsing and summarization, applications and license plate detection on moving vehicles, monitoring traffic jams, activity recognition, crowd management and gesture recognition, information retrieval, organization, representation and access to information, categorization, indexing, and content analysis, data structures for unstructured data, design and maintenance of such data structures, indexing and indexes, retrieval and classification schemes, use of codes, formats, and standards, analysis, construction and evaluation of search and navigation techniques, search engines and how they relate to the above, multimedia data and their representation and search, conversational intro to conversational AI, use cases of chatbots, NLU and dialogue management, design the flow of conversation, crafting training data, training the NLU model, understanding dialogue management, intent classification and entity extraction, using slots for context understanding, understanding NLU components, supporting multiple languages, voice bot, the bot, data mining, topics beyond conventional record data mining complex data structures, tree graph mining, sequence mining, web text data mining, stream data mining, spatiotemporal data mining multivariate time series data, high dimensional data clustering and mining social networking sites, mining data from multiple relations, multirelational data mining, privacy preserving data mining, distributed computing solutions for data intensive data mining, artificial and intelligence, introduction to intelligent agents, search based agents, informed and uninformed searches, local search algorithms, hill climbing, simulated annealing, local beam search, genetic algorithms, ACO, PSO, minimax algorithm, alpha beta pruning, knowledge representation and reasoning, logical agents, representation and reasoning using propositional and predicate logic, resolution, forward and backward chaining, DPLL, probabilistic reasoning, knowledge representation using Bayesian networks, exact and approximate inference from Bayesian networks, hidden Markov models, ethics in AI, explainable AI, machine learning, introduction to machine learning, various kinds of learning, supervised learning, unsupervised learning, model selection, Bayesian learning, map hypothesis, MDL principle, bias variance, decomposition, Bayes optimal classifier, naive Bayes classifier, Linear models for regression. AI and techniques for cybersecurity. Introduction to cybersecurity. Supervised learning for misuse signature detection. Machine learning for anomaly detection. Malware detection and classification. Network intrusion detection and classification. Detection and categorization of domain names. Profiling network traffic. Adversarial machine learning for malware detection. Eligibility. Employed professionals holding BEB.Tech with at least 60% aggregate marks and minimum 1 year relevant work experience after the completion of the degree are eligible to apply. Employed professionals holding MCA.M.Sc or equivalent with at least 60% aggregate marks with university level mathematics statistics as mandatory subjects and minimum 1 year relevant work experience after the completion of the degree are also eligible to apply. Working knowledge of computing and programming is required. Mode of examination. Mode of examinations applicable for students admitted in batch starting in October Nov 2024. Semester 1, 2 and 3 have mid-semester examinations and comprehensive examinations for each course. These examinations are mostly scheduled on Friday, Saturday or Sunday. Students need to appear in person for taking the examinations at the institution's designated examination centers as per the examination schedule, instructions, rules and guidelines announced before every examination. For Indian students, students can take their examination at any of our 33 designated examination centers in India at the following locations. South Zone, Bangalore, North, Bangalore, Central, Bangalore, South, Bangalore, East, Chennai, North, Chennai, Central, Chennai, South, Hyderabad, Secunderabad, Vijayawada, Vishakhapatnam, Kochi, Thiruvananthapuram and Coimbatore. North Zone, Delhi, Gurugram, Noida, Jaipur, Chandigarh, Lucknow and Pilani. West Zone, Mumbai, Navi Mumbai, Pune, Pimpri Chinchwad, Goa, Ahmedabad, Indore and Nagpur. East Zone, Kolkata, Bhubaneswar, Guwahati and Jamshedpur. For international students, in addition to the above locations, the institution also has a designated international examination center located in Dubai. To facilitate the learning of international students applying from any other location except India and Dubai, the mode of examinations will be online, which can be availed by meeting the requirements of the institute. To know more about the requirements of online examinations, click here. Indian students who are temporarily based out of India, type IT and software professionals working as software engineer, software developer, programmer, software test engineer, support engineer, data analyst, business analyst, who wish to transition to roles such as ML engineers and AI scientists, etc., should consider applying to this program. How to apply? Click on the below link and register and apply. Fill and submit your application form for your chosen program. Download a PDF copy of the application form. Pay the application fee of 1,500 rupees using net banking debit card credit card. Print the downloaded application form and note your application form number. Link also provided and comment section. Admissions open. Last date to 15 September 2024. Fee structure for students admitted in academic year 2004 to 2025 is as follows. Application fees rupees 1500, admission fees rupees 16,500, semester fees rupees 71,750. Easy monthly payment option with 0% interest and 0 down payment. Instant EMI option with 0% interest and 0 down payment is now available that allows you to pay program fee in an easy and convenient way. Instant online approval in seconds. No credit cards, CIBIL score required. Easy and secure online process using Aadhaar and PAN number. Anyone with a salary account with net banking can apply the option to submit fee using easy EMI with 0% interest and zero down payment. All the above fees are non-refundable. Click here important. For every course in the program, Institute will recommend textbooks. Students would need to procure these textbooks on their own. Thanks for watching. Please like, subscribe.